heat transfer. Before that, subscribe, share our video. Now we're going to the topic, heat transfer. As we have discussed before, heat is a form of energy. It is a form of energy that flows from higher temperature to the lower temperature, and heat transfer from one body to another in three ways. Heat transfer in three ways. These are: first one, conduction; the second one, convection; and the third one, radiation. Let's see each one by one. The first one, conduction. Conduction, it is a method of heat transfer, in solid and liquid, when two bodies or when two objects are at different temperature. By what? By the collision of particles. By the collision of particles. For example, if we take a substance, when heat it, then the particles get energy, heat energy. When they get energy, their average molecular kinetic energy increase. Due to this, there is a motion between particles. This motion of a particle collide each other. Due to this, there is a transfer of heat from one body to another. Such method of heat transfer is said to be conduction. The amount of heat energy or thermal energy, heat transfer per unit time, which is rate of heat flow, it is denoted by H, which is the rate of energy which is H, denoted by delta Q over T. Now let's consider a slab of a material with thickness delta L and area A, with temperature difference initial and surface A2 with temperature F, and heat flow, the rate of heat flow, which is H, it is directly proportional to temperature gradient, which is delta T over delta L, let it be equation 1, and again the rate of heat flow H directly proportional to area, let it be equation 2. Combine it, the rate of heat flow H directly proportional to area and temperature gradient, which is delta T over delta L. We call this quantity temperature gradient. Temperature gradient. Hence, H is the proportionality constant, which is K minus of K A delta T over delta L. We have this. And K indicate conductivity of the material. Conductivity of the material. H, rate of heat flow, which is given with a unit watt, since it is the ratio of energy per unit time. Watt energy, joule per second, is the unit for power, which is watt. Therefore, the rate of heat flow, H, is equal to minus of K A delta T over delta L. The negative sign indicates that it flows in the direction of a decreasing temperature. And materials with a larger value of K are good conductors of heat, and those with a smaller value of K are good insulators of heat. Now let's go to the second method of heat transfer, which is convection. Convection. This method of heat transfer is by the actual movement of molecules, in a fluid. Fluid is a name given for liquids and gas. For example, if we take a liquid in a container, when we heat it, delta Q, the molecules around the surface of the container gets heat. When a body gets heat, it will expand. Due to this, there is a change in volume. From the definition of density, density is equal to mass over volume. When volume increase, its density decrease. Due to this, it becomes light and it moves up, and heavier particles move downward. Again, when it gets heat, it will expand. Due to this, there is a change in volume, it increases. When it increases its volume, its density decreases. Again, it moves up. By such system, the whole liquid or the whole system gets heat. Due to this, by the actual movement of molecules, the whole system gets heat in liquid and gas, such as fluid, a substance that can flow, Such method of heat transfer is convection. Again, in this case, the rate of heat flow, the rate of heat flow, which is denoted by H, it is directly proportional to contact area A, and again it is directly proportional to pressure difference, which is delta T. When we combine these two equations, we get H is equal to H times area times delta T. In this case, H is the proportionality constant, which is called the convective surface coefficient. Convective surface coefficient. Then rate of heat flow, which is given in Watt, equals H, which is convective surface coefficient, times area times delta T. Now let's go to the third method of heat transfer, which is radiation. This is a method of heat transfer by electromagnetic wave. This is a third method of heat transfer. Heat transfer in vacuum by this method, and for example, when you stand some distance away from a source of heat inside a room, you may feel warm. This method of heat transfer is by radiation. Under radiation, let's see Stefan Boltzmann's law. The power radiated over all wavelengths from a surface is proportional to the force power of absolute temperature, which is the power radiated from the surface is proportional to the force root of temperature and area, and there is a proportionality constant, which is E, and Stefan Boltzmann constant, H, which is a power radiated from the surface, rho, Stefan Boltzmann constant, again it is a constant, E, emissivity range, it is between 0 and 1. This is the end for today. Next we'll see quantity of heat.